And this time it says that you had a rectangular garden, and the garden has an area of 225 square feet. The length of the garden is 7 feet more than twice the width. I know, you don't like these ones. So we're going to create an equation. So first thing, it's not going to be that bad once we break it down. We have a rectangular garden. We're looking at the area. So first of all, what's the area of a rectangle? Length times width. We'll call it length times width. Because we're going to write everything in terms of width. So you need to know that a rectangle is length times width. And let's see, it says create an equation in terms of W. That means when you write the equation here, you don't want L in it. You want everything to have a variable W in it. So let's fill into that formula what we do know. What do we know should be the A, the area? 225. So we'll at least start with 225 equals. Now go back to the scenario. We have that the length is 7 more than twice the width. So how do I represent that mathematically? 7 plus 2W. So I'm going to put it in parentheses. That is your length. And how should I represent width? Just W. So this is an equation in terms of W. That means W is the variable for the area. Okay? That's not too bad, right? Well, now I need to figure out what is the width and what is the length. So what do you think we should do next? There's lots of different ways we can go, but I want to see where you go. Solve for W. So if I'm going to solve for W, what do I have to do first? Distribute. Okay, so let's distribute the W to the right-hand side. So you have a little bit of room underneath. So 225 equals 7W plus 2W squared. Now what do you think you'd like to do? Factor. So we'll have to factor maybe. So let's move the 225, set it equal to 0. So we'll subtract 225. And when we do that, why don't we put this into standard form kind of at the same time? So we'll have 0 equals, what should go first if I write this in standard form? 2W squared plus 7W minus 225. Now there's two ways we can attack this. I'll make you do some of it by factoring, some of it with your calculator. Which way do you think is going to be faster for this one? Factoring or calculator? I didn't hear what you said. It's up to you. Calculator? Okay. So if I'm going to type this into my calculator, and I type 2W squared plus 7W minus 225, because let's think about it. If I was factoring this, I'd have to multiply 2 and negative 225, which is negative 450, and find two numbers that multiply to negative 450 and add to 7. Do you want to make that list? No. All right, so let's type it into our calculator really quick. So we'll go to y equals. Now instead of w, we'll use x. So 2x squared plus 7x minus 225. Now my calculator automatically resets to the standard window. Some of your windows might still be adjusted from last week, but if not, hit Zoom 6. Zoom 6 at least gets you back to where you started, and that's what I would suggest. So hit Zoom 6, and you should get a picture that looks like this. Can I see both x-intercepts here? Because that's what I'm looking for to solve. No, so I need to adjust my window a little bit. First of all, when I adjust my window, what is my y-intercept of this equation? If I'm in standard form, which number is the y-intercept? Negative 225. So I at least need to make my y values go down to negative 225. So I know my y minimum should maybe be 225, and the x is 10 is fine. So we'll go by, I don't know, I'll go by 25 today. But the x is, I can only see one x-intercept, right? When I graph this, I can see one, I can't see the other one. So what should I make the x minimum so I can get to the left here? What do you want to make it? 20. Negative 20? So graph that, and it does look like I can see both x-intercepts here. And that's what we're solving for, since we were set equal to 0. So I want you to take a moment. I want you to remember how we did on Tuesday of last week. Second trace. Which one do I choose for x-intercepts? Option 2, 0. And go on through and calculate for me. I'm going to let you guys do it because you know it takes mine forever to. Let's see. What x intercepts did you get when you traced here? What'd you get? X equals negative 12.5 and 9. Now we are talking about the length and width of a garden. So it has to be positive. So cross off negative 12.5. Then what we're going to learn in the next unit is called extraneous. The word extra is in there. So it's an extra solution. It doesn't work here. So we know that 9 is our width. So we know the width of the garden is 9 feet. And in order to find the length, we put 9 into that little fancy formula we wrote the length. 7 plus 2 times 9 is 18. Bless you. 18 plus 7 is 25. Yeah, you can do that. So, not too hard, right? You set up the equation, you put it in your calculator, you found the length and the width. Okay. That'd be loud and probably kind of smelly. Alright, so the next one is a little bit more involved.
But it doesn't add up. 9, 18 plus 7.
25. So you take 25 times 9 is 225. Just 25 times 8, so like think of quarters. 9 quarters would be 225.
Oh!
Alright, so this new one is a little bit more involved. Miss Upstrom, I don't know if any of you have Miss Upstrom. You guys might be too young to have her. But Miss Upstrom makes a quilt. She actually does sew, makes quilts. My mom and sister make quilts. That talent was not passed down to me, but she makes a quilt that is 4 feet by 5 feet. Okay? So she has a quilt. Now, if you don't understand this diagram, because you don't know quilts, let me kind of explain this to you. So the quilt is 4 by 5 feet. The quilt part is this inner box. All right, when you have a quilt, if you've ever seen a quilt, there's like an inside part, and then there's a border. The border around the quilt is this like outside rectangle. And that border, she has 10 square feet of fabric to make the blue border for her quilt. All right, so our question is, Ms. Upstrom wants to know, how wide should she make the border around her quilt, and every side of the border has to be the same. So you can't have like one that's 3 inches and one that's 8 inches. It has to be the same around the whole thing. So let's at least write down what we know. We know that this green part, the actual quilt, is 4 by 5 feet, right? So we know that this is 4 feet, and that side is 5, or vice versa. It doesn't matter. And we're going to be talking about area here. So just the green part, just the quilt, what is the area of the actual quilt? 20, right? So the area here is 20 square feet of just the quilt. Now, when Ms. Upstrom puts that border on, it says she has 10 square feet of border to work with. All right, so we have 10 square feet of fabric we have to make this border. And her question is, how wide should that border be? So the width, we're going to call it X. That's the width here. Now, it has to be the same all the way around. So the bottom part here has to be X in width. The side over here is X. And the top is X. I'm just writing that in so you see that all those borders have to be the same. Now, ultimately, we need to solve for X, but we're talking about area. So when I talk about area here, if I have 20 square feet here, how much fabric does she have for the border? 10. And it says she wants to use all of the fabric. So how big total will her quilt be when she's done? 30. So we're going to set up a formula. We're still using that length times width for area. We know that the area is going to end up to be equal to 30. That's the whole quilt. Now we have to come up with an equation for the area. So when I think about this, that means the whole quilt. So I'm looking at these outer borders now. The bottom part here is going to be equal to 4 plus what? 2x's. So this length is 4 plus 2x. And what's the length of this side here? 5 plus 2x. That's going to give me the area of the whole quilt. So we're going to put that into our formula. 5 plus 2x quill. So let's do that. Now let's do this one by factoring. You have enough room. All right, are we okay so far? What's the note?
I don't know what's boring. What's boring?
I remember.
Okay, so this whole side here, if I just like translated this down, this part is like 4, and then there's x and x right there. Does that make sense? So there's 4 for the width, but we tacked on the border, so this side is 4 plus x on either side. Did that make more sense to some of you? Okay, so now, Grace said we need to FOIL here. We need to get rid of the parentheses. Grace, who told me that? Someone told me that we had to FOIL. I don't know. Someone's idea was to FOIL. So let's distribute. We'll give Grace the credit. So we have 30 equals. All right, 5 times 4 is 20 plus 10x plus 8x plus 4x squared. Now, it's definitely not in standard form yet, but we can get it there. Let's subtract the 30 over and combine like terms, and then at the same time, do we want to try to put it in standard form? Or is that too much to do in one step? Do it. All right, what will come first if I put this in standard form? 4x squared. The x's go together. So plus 18x and minus 10. Yeah? All right, so that is our equation. Now that one doesn't look too horrible to factor, right? I can just split the middle here. Well, let me do one factoring problem today. So if I take 4 times negative 10, I get negative 40. What two numbers multiply to negative 40 and get me 18? That's not as bad as the last one. 2 and something.
Wait, 2 and 20.
2 and 20. Yeah, negative 2 and 20. You were close. You were close. All right, so let's split the middle here. So 0 equals 4x squared minus 2x.
Okay. You're gonna fight the dummy boys.
Well, 10x minus 10. That's not very nice. All right, and we're going to split our middle. So what's the GCF for the left group? 2x. So we'll pull out a 2x here. We'll have 2x minus 1. And the GCF for the next group? 10, which gives me 2x minus 1 again. Which is pretty nice numbers, because you'll get 0 equals 2x plus 10 and 2x minus 1. But we're not really done with this fact. How do I find the solutions, the possibilities for the x, the width of the border? Use the zero products law, which means I set each of these equal to 0. So I take 2x plus 10 equals 0. 2x minus 1 equals 0.
That's it.
What?
That's it, actually,
So far. So if I solve this one, if I subtract 10 and divide by 2, what does x equal? Negative 5. Okay, that's one solution. And if I solve this right one for x, what do I get? 1/2. Now remember, x here, when I go way back and look at my picture, x is the width of the border. How wide the border has to be. Can you have a negative border? No, so negative 5 gets crossed off. That's an extra solution. So that means that the border has to be half of a foot. Now half is per feet. We're talking about feet here. So the width of the border is 1/2 of a foot, or 6 inches. All right, so her quilt has to have a 6-inch border. Yeah. Half of a foot. Now, real quick, if my border can be 6 inches, right? Now think about it. That was using all of the fabric. We said in order to set this model, Miss Upstrom had to use all 10 feet of her extra fabric. And you can't have a negative border, right? So if she really wanted, let's come up with the domain for this box here. What is the smallest that the border could be, even if she didn't use all her fabric? She can't have negative because she had no border on her quilt. Yeah, so I could have 0. I'm going to use interval notation. So I'm going to say the border could be 0 inches. She can put no border on. What's the biggest border Miss Ekstrom can use? 1/2 of a foot. Why can't we go beyond 1/2?
Because then she would need more fabric.
She would need more fabric, right? Because 1/2 border, 1/2 of a foot, use every bit of fabric she has. Okay, so that one was long. That's the longest one we're going to do today. Go ahead and flip your paper over. Now we're going to switch gears. We've been creating equations in factored form, and we use our calculator. We use factoring to solve them. The next 1/2, I haven't decided if we're going to do part B yet, but at least part A here. We're going to talk about equations in vertex form. So this graph shows the jump of a dolphin. It says the axis of symmetry for this parabola is at x equals 2. Now remember, the axis of symmetry goes through the vertex. So that's right here, actually. So we know that x equals 2 there. That's your axis of symmetry. And the highest height that the dolphin jumps is 7 feet. So between that axis of symmetry and knowing the max height is 7, that tells me we know what the vertex is. The vertex is going to be at 2, 7. Okay, so that's going to be important. You can label your picture. I'm also going to write it over here. 2, 7. Now, if the path of the jump goes through the point 5, 5, so that means the dolphin ends up jumping 5 feet out and 5 feet high. We want to know what is the equation of the path of the dolphin's jump. Right? What equation models that parabola? So we know a couple of things. We know the vertex, and we know one point on the graph that's not the vertex. It gives us some hints. It says, plug the information you know into vertex form. So let's at least write down the basic vertex form. Y equals. It would be A times x minus h squared plus k. We didn't really use like the basic formula a lot, but that's vertex form for you. We saw it once in a while. We know that information. Now, what part of this formula represents the vertex? What letters? H and K. So I know that this vertex here, the 2 and 7, that's going to give me the H and the K. So let's at least fill in that H and K in for H and K in the formula. So don't do Y, don't do A, don't do any, just, well, it says here we're solving for A, so you can at least write A here. A, leave X and Y blank for now. If I put 2, and I need the negative 2, right, not positive, so I'll put minus 2 here, squared, and K will be plus 7. Now here's the thing. I'm trying to find what A is. I know, in general, I know what H and K is, so I need to know the coefficient on the side. So this kind of is similar to something you did back in Algebra 1, but I need to now use something to fill in for my X and my Y. What should I use? 5 and 5. This 5 is an X value. That 5 is a Y value. Yes. Well, we don't care, so don't worry about it. Don't make it more complicated. Yep. So let's put these in. So 5 goes in for Y, and the other 5 goes in for X. Now we have to solve for A. So what would you do here, gentlemen? I love your moves, but yeah, simplify. So 5 equals A times 5 minus 2 is 3, and 3 squared is 9. So I'm going to write that as 9A plus 7. Kaylin, you could probably do it, but we'd have to know, like, they'd have to tell us. They'd have to say, like, this is a horizontal compression, so put A in, like, the parentheses or something. No. Yes? Yep, you'd subtract 7. I'm going to scoot this over here. So I have negative 2 equals 9A, and I divide by 9. So that gives me that A, my leading, or my vertical compression here, is negative 2 over 9. So overall, how do you write the equation? Yep, Y equals negative 2 over 9. Oh, parentheses. I'm writing vertex form here. Yes, sorry, I was listening to their conversation. X, use the vertex here. Minus 2 squared plus 7. That's your dolphin's jump. Alright, now, part B is very similar, but I actually want to skip that one. We can move on to example 4. 2 more examples to do here, okay? We're close. Now this one switches it up. So we've done factored form, we've done vertex form. Now let's talk about writing models when we're given parts of the equation. So this one says a company has a cost, C, here's the cost, to create something, right? So when you manufacture something, it costs you money. You have to pay employees, you have to pay for materials. Then R gives the equation of the revenue. What does revenue mean? Like your product, right? The money you bring in. So it costs you something to make things, but then you make money when you sell it. So they want to know how many items should the company make so that the revenue and costs are equal. That means break even. When you bring in the same amount of money that you spent. Okay, so how should I set the two equations equal? So I'm going to take the equation for the cost and set it equal to the equation for the revenue. Now, there's a couple different places we can go here. Right? There's 2 correct paths. We're going to end up using our calculator, I'll tell you that, but do you want to use your calculator now or do you want to wait? It's up to you. Let's wait. You want to wait, okay. Or do you want to do it now? It's up to you.
Wait, do we only get one chance to use that?
No, you'll get the same answer either way.
Okay, let's find out.
We can simplify it then. How do you want to simplify it? Move the x over. So I'm going to do this all in one step. I'm going to add x squared, ladies and gentlemen, and I'm going to subtract 225. I'm going to do it all at once. Because that way, the right-hand side equals 0. And what do I get on the left-hand side? X squared minus 150x plus 2,600. So that's the quadratic equation. Now the thing is, you could factor this. I mean, we can factor it if you want to, but if we factored this, you need to find 2 numbers that multiply to 2,600 and add to negative 150. You want to come up with those? I'll give you the rest of the period. Just sit and find those numbers. No? So how can I use my calculator? Let's graph it. So type it first into the y equals. So we have x squared minus 150x. Bless you. Was it plus 2,600? I can't even remember. Yes. Now when I graph this, first of all, I'm going to go back to my standard window just because it's easier to see. I'm going to go to Zoom 6. Can you see anything? No. Now, so first of all, that means I can't see the x-intercepts, but when I look at the equation, let's at least change the window a little bit so we can get an idea. When I come back to my equation, what's the y-intercept of this one? Yeah, this is your y-intercept. So I know that I need to make the y max at least 2,600. So let's at least start there. Even though we don't really know what else to do with the window, let's change the y max to 2,600. I'm going to go by 100, I think. So when I hit graph, at least I see where the parabola is going, right? I can see that the parabola is coming down, and eventually it's going to come back up over here. So now I know I need to adjust my window to the right. And where do you want to make your x's? How high do you want the x's to go? We'll start with 100. That works. Do 100. I'm going to go by 10s. And we'll graph. Alright, well I see one of them, but 100 wasn't big enough for the other one. So now let's adjust our x's again. How high should we make it this time? You want to try 200? So I'll do 200 here. If I hit graph, oh, I can now see it. That works. I can't see the bottom, but do you think that's okay? I'm just looking for which feature of the graph. The x-intercept. So I can see the two x-intercepts. So I want you to take a second. I want you to trace those two x-intercepts. Now here's the only thing. Some people in the last class were having a little trouble. So if you need help, you can always change your x minimum, or your y minimum, I'm sorry. Why don't we make the y minimum like, I don't know. No, I'll do negative 2,000 because I think it might be pretty big. Let's see. Yeah, it doesn't quite get you to the bottom, but it'll help with tracing where the tracer is to be able to see a little bit more of your graph.
There it is.
How do you find the? Okay.
So at the bottom, when you trace, if you're having trouble finding where it's at, it tells you where x is at down here. So mine's at 95. So if I like move to the left, it's telling me like, oh, it's bringing it to the left. So you would just go until you can see it either direction. Okay, so I'm gonna come around and help you first. You guys did. I think a lot of you did. So 20 and 130 items. So either of those would allow this company to break even. So their cost is equal to the amount of money they bring in. Good. All right, last one here. The numbers are a little smaller and nicer. We don't have to change our windows so much. The function a equals 2.4t minus 0.1 t squared. Now those numbers aren't really pretty, but the answer is like with the graph looks a little nicer. So it gives the amount of a medicine that's like in your bloodstream. So that's measured in micromilligrams, and it's the number of hours after you take. So like you take like an ibuprofen or an aspirin, and after a certain amount of time, the amount of medicine in your body wears off. So when is the amount of drug equal to 8 micromilligrams? How should I set up this equation? Where does the 8 go? And for A, because A is the amount. So we want to know when is the amount equal to 8. Now there's two ways to do this here. I'm going to do it differently than what we've done, just to show you an option. Okay, yes, you are perfectly able to subtract 8 from both sides, set it equal to 0, find the x-intercepts. That's totally fine. I'm just giving you an option here. This time, when we type this into our calculator, I want you to type 8 into y1, and this side into y2. We're going to see where the lines intersect. Where are they equal to each other? You can graph 2, so you clear out all the ones you have. You put in f of 1 and f2. 8. Yeah, just type y equals 8. And 2.4x minus 0.1x. Now I'm going to go back to my main window, Zoom 6. Now again, you could totally solve it for 0, like subtract 8 and graph it like we have. I just wanted to show you an alternate way here. So when I go back to my main window, I went Zoom 6. That takes me standard. I can see one intersection point. I probably have one out here. So I'm going to at least change the x max to be, I don't know, I'm going to try 30. And we'll see what it does. There, I can see both now. So we have not, I don't think, maybe we have, maybe a while ago, done intersection on our calculator, at least in a little while. So our job is to figure out the red is the equation for the medicine in your blood. The 8 is the amount we want to find. Yes, Bobby.
Oh, hold on.
So I went back to the standard screen, Zoom 6.
So I'm there now?
Yep, and then I changed the x max. I made it 30.
Oh.
So I could see both. So when I find the intersection, I do second trace, and I'm going to choose number 5 this time. Now the nice thing about choosing 5 is you don't have to move the cursor. I mean, you can a little bit. I would at least bring it maybe a little closer to this guy. But you bring it a little closer, you just hit enter once. It automatically puts the cursor on the second curve, on the red graph. You hit enter again, and hit enter a third time to guess. And it tells you this point right here is 4, 8. I'll help you. You did the other one. So we're solving this one by graphing. The points at 4, 8 is one of the intersection points. And then if you did the other one, I would bring this cursor this time over towards the other intersection point. Enter, enter, enter. And you get 20. So it means 28 is the other way. Now, let's think about what these answers mean in terms of this problem. So this is talking about it would take 4 hours or 20 hours until there are 8 micromilligrams of this drug in your system. So thinking about, because that kind of seems weird, like 4 and 20, how does that happen? So if I think about the graph here, so think about like when you take like an ibuprofen or something, right? When you take it, you have none of the medicine in your system. As you like the medicine like dissolves in your stomach and is absorbed into your bloodstream, the amount of medicine increases, right? So like, as soon as you take it, you don't have the full amount in your blood, correct? So it's increasing. So once you get to 4 hours in, you had 8 micromilligrams. Eventually, somewhere at the top, it maxes out and it starts decaying the amount in your blood, and it comes back down. Okay, does that make sense? All right, now here's what I need you to do tonight.